Hello everyone. This video is on section 10.3, part 1, titled Introduction to Logarithms. In this video, I'm going to be going over a version of the Knewton Alta assignment for section 10.3, part 1. Now please understand that the questions I see in this video may not be the same questions you see when you work on the assignment on your own. But the objectives are the same, the types of questions should be similar, so I'm hoping that watching me go through a few of these here help you in some way when you're working on the assignment yourself. Alright, so here's the assignment page. Now you will not see the words preview of. You'll just see the title of the assignment. Then in the upper right corner you have your mastery bar telling you how far along you've gotten. Beneath that you have your objectives. Looks like there are 2 objectives for this particular assignment. And then on the current objective there should be a question related to it below that. And at the bottom of every question box should be a feedback button, which you can send feedback to Knewton through. You will not see the instructor cheat button, right? That will not be there. But you will see a more instruction button, which you can click on and get further reading material, maybe videos related to the objective for that particular question, and hopefully those help you out. Alright, so the first question here is on the objective, evaluate a logarithmic function, or just evaluate a logarithm. So first, before I get into the questions, I want to do a little discussion, a little lecture on logarithms, right? These things called logarithms. Alright. So logarithms. It's important to know that logarithms are exponents, right? I'll write that up here. Logarithms are just exponents. And I'll show you what this means here in a second. So if we have the following statement, the following exponential statement, say I have a base b raised to an exponent, say m, if that's equal to some number, say n. Right? So this is an exponential statement. Then we would say that the exponent m is the logarithm of n base b. And the way that's abbreviated is this: log of n base b. Right? So log with the little number here as a subscript. This little number here is the same as this number here. Right? Those are called the base. Right? So base b, this little b here is the base of the logarithm. And then remember what I wrote up here, that logarithms are exponents. See the exponent over here? That is what this log expression is equal to. So when you see an log, when you see this logarithm expression, what it's equal to will be an exponent. So that's what I mean by logarithms are exponents, right? Logarithms are equal two exponents. And then the number here on the right side goes inside the logarithm. And this number in the logarithm is either called the input or the argument of the logarithm, argument slash input, right? And that's this here. And this goes both ways as well, right? So I shouldn't have had an if-then. What I should have is a back and forth arrow, if and only if. So you can go back, you should be able to go back and forth between these expressions. Right now, this one on the left is called, exponential form. And the one on the right here is called, logarithmic form. Now, there's a lot of letters and junk, B, M, N, logs. Let me show you some examples with some numbers. All right. So we know that, say, 2 to the third power is 8. Right? 2 to the third power is 8. So that's a statement that's in exponential form. So if 2 to the third power is 8, we would say that the exponent 3 is the logarithm of 8, the log of 8 base 2, right? Base 2. 3 is the logarithm of 8 base 2, log of 8, and then a little 2 underneath the log symbol. Or 3 is the log base 2 of 8. Sometimes people might say it that way. And I can go the other way around. If I say, 5 is the log base 3 of 243, this is the same meaning. Right, this has the same meaning as the following. Remember, the little number here is the base when you write the exponential form. So the little number 3, that's the base. And then what the log is equal to, the 5 here, is the exponent on that base. So we have 3 to the 5th power is 243. And sometimes I've seen people draw this kind of stuff up where you have the base raised to the 5th power and then equals the argument here, equals the number inside. Same thing here, 2 to the 3rd power equals 8. So I'll do one more like this. Let's say let's say -2 equals the log base 4 of 1/16. -2 is the log base 4 of 1/16, and that's because, and this is equivalent to saying the following: the little number under the log, the base 4 raised to the -2nd power, would be equal to 1/16. Right, hopefully you remember your negative powers, right? 4 to the -2nd is just the reciprocal of 4 to the 2nd, so 1/16, positive 1/16. Okay, and you should be able to go back and forth between these, right? If you're given a statement in exponential form, you should be able to translate it to the equivalent logarithmic form, and vice versa. Now I showed you the logarithmic form is easy to change to exponential. You take, again, the little number raised to the number on the other side equals the number inside the log, right? That'll be your exponential form. And then when you have exponential form and you're changing to log, remember the exponent equals the log. Logarithms are exponents. The exponent 5 equals the log base 3, right? Whatever the base on that power is of 243. Or you could say 5 is the logarithm of 243 with a base of 3. However you want to say all that. They mean the same thing. Okay. So, this initial question we're given. We're asked to find the exact value. I'll keep this up here. Now, you know what? I'm going to write this on a separate page now. So here's exponential form. So b to the mth power equals n. You can go back and forth, and these have the same meaning. This means the same as m equals the log of n base b, or the log base b of n. Okay, and again, b to the mth equals n, b to the mth equals n, m equals the log base b of n. They mean the same thing. So I'm going to keep this on top of this page here, and we'll keep referring back to it. Now, we are asked to find the value. We have log base 1/2 of 4 equals x. Log base 1/2 of 4 equals x, and we're asked to find x. All right, find x. Well, if you'd like, you can change it to exponential form. This means the same as 1/2 to the x. 1/2 to what power is 4? That's really what a logarithm is asking you for. When you're given a logarithm, they're really saying, what number do I raise this little base to get the number inside? All right, 1/2 to what power is 4? And we can set this up so that both sides have the same base, and then we can use that 1-to-1 property, right? If you remember section 10.2 at all, there was a 1-to-1 property for exponential equations. This is actually 2 to the negative first, right? That's 1/2 to the x. And then 4 is 2 squared. And then power to a power property, this is 2 to the negative x equals 2 to the second. And now I can apply that 1-to-1 property that we've seen. If two expressions with the same base are equal, their exponents must be equal. So negative x must be equal to positive 2, meaning that x must be equal to negative 2. And let's check that. Let's check that negative 2 is the correct response here. Is the log base 1/2 of 4 equal to negative 2? Well, let's see. If I change this to exponential form, this is 1/2 to the negative second power equals 4. And this is true. Right, because 1/2 squared is 1/4, so 1/2 to the negative second would be the reciprocal, which would be positive 4. This works. But yeah, when you're given the log base b of n, you're just really asking, what power do I need to raise b to get n? Right? What power do I need to raise 1/2 to get 4? I need to raise 1/2 to the negative second power to get 4. Right, so back on the assignment, the value of x here is negative 2. Yeah, but again, you should be able to go back and forth between exponential form and logarithmic form, understanding that exponents are logarithms, right? And when you see a log equal to some number, that number is the exponent on the base of that log when you change it to exponential form. All right, and after every question, there should be an answer explanation. Please read these. Now if you got it right, read through it, glance through it just to make sure you got it right for the right reasons. All right. Or maybe they went through some alternate method that you like better, and you can go about using that in the future questions. Now if you got it wrong, definitely read through the answer explanations, try to figure out why you were wrong, and hopefully you can learn from your mistakes. Alright, the next question. Same objective. We're given a logarithmic statement and asked to find the value of the variable, right? Wherever x is. So once again, I'll go back to my paper where we have the conversion between exponential form and logarithmic form up top. And this time we're given this statement: the log with a base of 2 of x. So the logarithm of x base 2 equals -6. Find x. Well, if I change this to exponential form, remember this little number here is the base. The number the log is equal to is the exponent, right? Logs are exponents. So 2 to the -6th power equals the number inside, equals this argument, equals x. And there, x is solved for. X equals 2 to the -6th power, which would be 1/64. Right? Because 2 to the 6th power is 64. 2 to the -6th power would be the reciprocal of that, right? 1/64. And that's what I'll enter. X equals 1/64. Yeah, again, all you're really needing to do is be able to go back and forth between exponential and logarithmic form. Next question. So I mean, it's the same objective really, but all they're asking you to do is change the form. They're not really asking you to solve for anything or simplify stuff. Just asks us to convert between exponential and logarithmic form, and that is all. Alright, so I'll go back to my paper where we have the conversion up top here. So we're given an expression in exponential form, right? 7 to the x power equals the square root of 7 divided by 7. And this statement here is equivalent to the following. Remember, the exponent, x, is the logarithm. So x equals the log. Now the base on the log is the same as the base on the exponent, right? The base on x was 7. So log base 7 of, and then the number on the other side is the argument of the logarithm, right? The input of the log. And this is all they wanted us to do, right? Just change to that logarithmic form an equivalent statement in logarithmic form. Right, so back in the assignment, right, it's left side I had x equals the log, the base on the log is 7, and then the expression inside is that number on the other side, the square root of 7 divided by 7. And that should be enough. Right, that's all they're asking us to do. Right, and once again, read through the answer explanations, pay attention. Alright, next question. Same objective. Right, same objective. So once again, this time we're given an expression, we're given an equation that's a logarithmic statement, and I want to change it to exponential form. Right, so back to my paper. So let's put a little wave here. This is a new problem. So we have logarithmic form. We have -5 equals the logarithm base 5 of 1/3125. So an equivalent statement in exponential form, remember this number here is the base, the little number underneath the log, the subscript. That's the base. What the log is equal to is the exponent. So 5 raised to the -5th power equals the argument, the input of the log, equals 1 over 3,125. And that is all we are asked to do. Just change forms. So here we have, base 5, exponent is what the log is equal to, -5, and then that's equal to, the argument of the log, 1 divided by 3,125. Simple as that. Okay, next question. So again, same objective, convert between the forms. So here we're given an exponential statement and asked to write it as a logarithmic statement. All right, so the exponential statement we're given is 4 to the -1/2 power equals 1/2. And I'm converting this to its equivalent logarithmic statement. And remember, the exponent I'll write on its own side. So -1/2 equals the logarithm. Exponents are logarithms. Logarithms are exponents. So the log, and then what's the base on this exponent of -1/2? It's base 4. And then the input of the logarithm, the argument, is the number on the other side, right? 1/2. So the log base 4 of 1/2 is -1/2, and this is what they want us to enter. Right? Fill in the blanks on that logarithmic statement. So yeah, the expression on its own side is the exponent, -1/2. The base on the log is the base on that exponent, which is 4, and then the number on the other side, the 1/2, positive 1/2, is the argument or the input of the logarithm. Great. Pretty easy, hopefully. Again, this should be, after some practice, easy to do, easy to go back and forth between exponential form and logarithmic form of a statement. I got just one more of these, and once again I'm given an exponential statement and asked to convert it to a logarithmic statement that means the same thing. Let's do a little wave here. Now the exponential statement we're given is 2/3 raised to the -2nd power equals positive 9/4. There's exponential form. Now remember, when I convert this to logarithmic form, the exponent is equal to the logarithm. The exponent here is -2. That'll get its own side, and this equals the logarithm. And what's the base on this exponent of -2? The base is 2/3, so the subscript here is log base 2/3 of, and then 9/4, right, is the input, the argument of the log. And that's all they want, right? They just want us to transform it from an exponential statement to an equivalent logarithmic statement. Both of these mean the same thing. They're just different looking. All right, so back here, right, the exponent, -2, gets its own side, equals the log with a base. Now the base on -2 is 2/3, so that'll be the base on the log. And then the argument is the number on the other side, the 9/4. Wonderful. Okay, and then we're back. The last couple questions should be on evaluate a logarithm. Right? So again here now, this one they're saying the log base 16 of 4 equals what? So 16 to what power would be 4? Well, that would be to the half power, right? The square root of 16 is 4. Remember, square root was the half power, 1/2 power. But I'll do this another way. I'll actually do it on paper. All right, so again, we're given this statement. We have the log base 16 of 4 equals what? Right. Now if I convert this to the equivalent exponential statement, this is 16 to the x power, 16 to what power, equals 4. And then we can apply, the one-to-one property. Well, once we get both sides with the same base, right? These don't have the same base right now, but I can get them to be the same base. Right? 16 to the x is the same thing as 4 to the second to the x, right? So I got power to a power equals 4 to the first, which is just 4. And then power to a power, here we have 4 to the 2x power equals 4 to the first power. Now both sides have the same base. We can apply that one-to-one property. If two expressions have the same base and are equal, then their exponents must be equal. So 2x must be equal to 1. Dividing by 2 means that x must be a half. And that works, right? I told you already, 16 to the 1/2 power, the square root of 16 is 4, indeed. So the log base 16 of 4 is a half, right? The log base 16 of 4 is 1/2, right? Since 16 to the 1/2 power equals 4. But the answer is 1/2, right? The value of x that satisfies that statement is 1/2. Great. And then I should have one more like this, where I have a logarithmic statement and some variable to find the value of. Alright, now there's not a variable here, but I will set one up. Alright, make it just like the other ones. Alright, so you see they even have x equals. So what's the log base 4 of 1/16? Now that'll be -2. I can already tell you that right now. 4 to the -2 power would be 1/16. So the answer is -2, but let me write this out. Right. So we're asked to find, the log base 4 of 1/16. Now say I didn't know that this was -2, right? Say I don't know what this is off the top of my head. Well, then I'll say it's unknown. Right? I don't know what it is, so I'll call it x. And then I change it to, the equivalent exponential form, so 4 to the x equals, 1/16. Which, this is kind of redundant here. This is ridiculous because, you should know that 1/16 is, 4 to the -2nd, and therefore, using the one-to-one property, right, both sides now have a base of 4, and if both sides have a base of 4, then and they're equal, then their exponents must be equal. So x must be equal to -2. So that means, the log base 4 of 1/16 is -2, right? Since 4 to the -2 power is 1/16, right? They both mean the same thing. All right, so -2 is the value of that logarithm. All right, and it should be, again, very simple. After some practice, it should be easy to go back and forth between exponential form and logarithmic form. All right. Great. All right, and then that should be it for this particular assignment, this version of this assignment. As I said at the top of the video, right, the questions I saw here may not be the same questions you see, but the objectives are the same. The types of questions will be similar. So I'm hoping that watching me go through these 8 questions here help you in some way when you're working on the assignment yourself. And thank you very much for watching.